November 12th, 1942, Richmond Shipyard Number Two, California. The autumn sun had barely cleared the East Bay Hills when Phyllis Gould pulled on her leather welding gloves and adjusted the dark glass shield over her face. Around her, the massive skeleton of a Liberty ship stretched 441 feet from bow to stern, its bare steel ribs jutting into the morning sky like the carcass of some prehistoric beast. She was 23 years old. 4 months earlier, she'd been a secretary. Now she was helping build the instruments of American victory, one white-hot weld at a time. Above the shipyard, a massive banner proclaimed an impossible deadline: 4 days. Management had challenged the yard workers to construct an entire cargo ship from keel to launch in just 96 hours. Traditional shipbuilders back east had laughed at the announcement. Ships took 6 months to build, maybe 8 if you were working with an inexperienced crew. The idea of completing one in less than a week wasn't just ambitious, it was lunacy. Phyllis didn't care about the skeptics. She had a job to do. Her electrode touched steel, and the world exploded into brilliant white light. Sparks cascaded around her in a waterfall of molten metal, the air filled with the acrid smell of burning flux and superheated iron. This was welding, a technique that most of America's established shipyards had dismissed as dangerous, unreliable, and fundamentally unsuited for serious maritime construction. But here in Richmond, at shipyards that hadn't even existed 2 years ago, welding wasn't just accepted, it was revolution. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. 4 days later, on November 12th, the Liberty ship Robert E. Peary slid into San Francisco Bay, fully complete and ready for war. Total construction time, 4 days, 15 hours, and 29 minutes. The previous record had been 10 days. Phyllis and her fellow workers had shattered it by more than half. But the real story wasn't the record. The real story was how a construction engineer, who'd never built a ship in his life, had revolutionized an entire industry, defied centuries of maritime tradition, and created a production system that would help win the greatest war in human history. His name was Henry Kaiser, and his forbidden innovation would save not 50 million factory hours. It would save something far more valuable. It would save the war itself. The story begins not in California, but in the mind of a man who understood absolutely nothing about shipbuilding, and for that very reason could see what everyone else had missed. Henry John Kaiser was born on May 9, 1882, in Sprout Brook, New York. His father, Frank Kaiser, had immigrated from Germany a decade earlier, worked as a shoemaker, and married Mary Yops, daughter of German immigrants. Young Heinrich, as he was called before Americanizing his name, grew up watching his father's hands transform leather into shoes through patient, methodical craftsmanship. But Henry didn't want to make shoes. He wanted to make his mark. At 13, he dropped out of school and took a job as a cash boy in a dry goods store, running money and packages between customers and the cashier for $3 a week. Within a year, he'd talked his way into a photography apprenticeship. By 16, he was managing the photo studio. At 20, he'd saved enough to buy his own photography business in Spokane, Washington. The pattern was clear early. Henry Kaiser looked at systems, identified inefficiencies, and reorganized everything to work faster and better. In 1914, at age 32, Kaiser shifted from photography into road construction. He'd been hired to photograph a highway project in British Columbia and recognized that the construction process was hopelessly disorganized. Men waited for equipment. Equipment sat idle waiting for materials. Materials arrived at the wrong locations. Kaiser convinced the contractor to let him reorganize the workflow. The project finished ahead of schedule and under budget. Within months, Kaiser had his own construction company. Over the next 2 decades, he built a reputation for taking on impossible projects and completing them through sheer industrial efficiency. He helped construct highways throughout the Pacific Northwest. He won contracts for the Hoover Dam, where his company was part of the 6 companies consortium that tamed the Colorado River. He worked on the Bonneville Dam and the Grand Coulee Dam, massive Depression-era projects that brought electricity to the rural West. He built the approach roads to the San Francisco-Oakland Bay Bridge, But Kaiser had never built a ship. He'd never even worked in a shipyard. This ignorance would turn out to be his greatest advantage. In 1940, with Europe already engulfed in war and Britain desperately short of merchant vessels, the British government approached American shipbuilders for help. They needed cargo ships to replace the hundreds being sunk by German U-boats in the Atlantic. The British had a simple design, based on an old tramp steamer, basic, utilitarian, powered by a reciprocating steam engine that was practically obsolete but easy to manufacture. They called it the Ocean-class freighter. Established shipyards on the East Coast submitted bids ranging from 6 to 8 months per ship. The British were disappointed but resigned. Traditional shipbuilding was slow. You laid the keel, built the frame one section at a time from the bottom up, riveted thousands of steel plates to that frame, installed the machinery, fitted out the interior, and finally launched the finished vessel. The process required skilled workers, especially riveters, who worked in teams to drive red-hot metal pins through pre-drilled holes and hammer them flat. A single ship might require over 1 million rivets. Each rivet had to be heated in a forge, carried hot to the installation point by a catchboy, driven through the hole by a bucker, and flattened by a riveter with a pneumatic hammer. The work was skilled, dangerous, and time-consuming. Henry Kaiser looked at the British specifications and saw something different. He saw an opportunity. Kaiser's bid promised to deliver ships in under 200 days. The British were skeptical but desperate. They awarded contracts to several American builders, including Kaiser's newly formed Oregon Shipbuilding Corporation in Portland. Kaiser immediately set about revolutionizing everything. His first decision shocked the maritime industry. He would weld the ships instead of riveting them. Welding had existed for decades, but traditional shipbuilders viewed it with deep suspicion. Riveted ships had centuries of proven reliability. Rivets created flexible joints that could absorb the stress of a ship working in heavy seas. Welding, the skeptics argued, created rigid joints that would crack under stress. Welded seams were prone to failure. A welded ship might break in half during a storm. Beyond the technical concerns, there was institutional resistance. Shipbuilding was a craft with ancient traditions. Master shipwrights had spent years learning their trade. The idea that you could teach someone to weld in a few weeks and have them build ships offended everything they believed about their profession. Kaiser didn't care about tradition. He cared about production speed and worker availability. Riveting required teams of highly skilled workers. The riveter needed years of experience to know exactly how hard to strike. The bucker needed to hold the bucking bar at precisely the right angle. The heater had to keep the forge at the correct temperature. If any member of the team made a mistake, the rivet was ruined and had to be removed and replaced. In contrast, welding could be taught in weeks. An electric arc welder needed to learn how to strike an arc, maintain the correct distance between electrode and metal, and move at a steady pace. That was it. A moderately coordinated person could learn acceptable welding technique in less than a month. This mattered enormously because in 1940, America was about to face a massive labor shortage. Kaiser's second innovation was equally radical. He would build ships in sections, not from the keel up. Traditional shipbuilding assembled everything in sequence at the shipway. You couldn't install the upper decks until the lower hull was complete. You couldn't add superstructure until the main deck was finished. Everything was sequential, which meant most workers spent most of their time waiting for the previous step to be completed. Kaiser proposed building entire sections of the ship simultaneously at different locations. Hull sections could be fabricated in one area, deck sections in another. The engine room could be largely assembled before installation. Then all these massive prefabricated components would be brought together at the shipway and welded into a complete vessel. This was assembly line thinking applied to shipbuilding. Henry Ford had proven that breaking complex manufacturing into discrete steps and standardizing components could dramatically increase production speed. Kaiser would do the same with ships. The third innovation was the workforce itself. Traditional shipyards hired experienced maritime workers, men who'd grown up around boats and learned the trade through apprenticeship. Kaiser couldn't find enough such workers. America didn't have them. So he hired anyone willing to work: farm workers, former secretaries, housewives, elderly men, people with disabilities that prevented them from serving in the military, women, especially women. By 1943, women made up a significant percentage of Kaiser's workforce. They worked as welders, crane operators, ship fitters, electricians, pipe fitters, and in virtually every role except the heaviest physical labor. This wasn't idealism, it was practical necessity, combined with Kaiser's fundamental pragmatism. He needed workers desperately, and couldn't afford to reject half the population because of gender. He couldn't reject black workers because of race. He couldn't reject older workers because of age. If someone could do the work, they got hired at equal pay. The Richmond and Portland shipyards became the first truly integrated industrial workplaces in American history, not through government mandate, but through wartime necessity, and one industrialist's refusal to let prejudice interfere with production. The results were extraordinary. In January 1941, Kaiser's Oregon Shipbuilding Corporation launched its first ship, the Star of Oregon, in 244 days. Slow by later standards, but respectable for a brand new yard with inexperienced workers. Then the improvements began. February, 220 days. March, 195 days. April, 160 days. The workers were learning. The prefabrication system was being refined. The welding techniques were being perfected. Then came December 7th, 1941, Pearl Harbor. Everything changed. Suddenly, America wasn't just helping Britain. America was fighting for its survival against enemies on two oceans. The country needed ships immediately, not hundreds, thousands. Cargo ships to carry troops and supplies, tankers to move fuel, troop transports. The existing merchant fleet was nowhere near adequate. American industrial might would have to perform a miracle. The government turned to Henry Kaiser. By early 1942, Kaiser was operating 7 massive shipyards, Richmond Numbers 1, 2, 3, and 4 in California, Oregon Shipbuilding in Portland, Vancouver on the Columbia River in Washington State, Swan Island in Portland. These weren't traditional shipyards that had been expanded. These were completely new facilities built specifically for mass production using Kaiser's methods. The scale was staggering. At peak operation, the Richmond yards alone employed over 90,000 workers. 3 shifts, 24 hours a day, 7 days a week. The yards operated with the intensity of an organism fighting for survival, which in a sense they were. The Liberty ship became Kaiser's canvas. The design was deliberately simple, 441 feet long, 57 feet wide. A displacement of 14,245 tons, powered by a 2,500 horsepower triple expansion reciprocating steam engine, the kind of power plant that had been common on freighters in 1900 but was considered obsolete by 1940. Kaiser didn't care that it was obsolete. He cared that dozens of different manufacturers could build them without requiring scarce resources or specialized expertise. The hull was welded steel. 5 cargo holds could carry 9,140 tons of cargo. Tanks on the deck, airplanes, locomotives, ammunition, food, medicine, jeeps, whatever the war effort needed. The crew complement was 44 merchant mariners plus up to 35 Navy armed guard sailors who manned the defensive weapons. A 3-inch gun mounted on the stern, a 5-inch gun on the bow, 8 20mm anti-aircraft guns scattered around the deck. These weapons turned every Liberty ship into a combatant, not just a cargo vessel. The ships were never intended to be permanent. They were expected to survive a few Atlantic crossings, maybe get torpedoed, maybe make it through the war. Naval architects called them ugly ducklings. They weren't fast, maxing out at 11 knots in calm seas. They weren't comfortable. Crew accommodations were Spartan. They weren't sophisticated, but they could be built quickly and in massive numbers. That was all that mattered. By mid-1942, production time had dropped to 70 days on average, then 60, then 50. Kaiser's workers were becoming extraordinarily efficient. The prefabrication system meant that when a hull section arrived at the shipway, it was already complete with internal framing, piping, and electrical conduits installed. Welders simply joined these massive components, and the ship began taking shape at astonishing speed. The welding itself had evolved into a science. Kaiser's yards employed welding instructors who'd developed standardized techniques. New workers learned on practice plates until they could produce consistent, strong welds. Quality control inspectors X-rayed critical seams to verify integrity. The early fears about welded ships proving fragile were gradually being dispelled by actual performance data. Liberty ships were holding together in Atlantic gales and surviving torpedo hits that would have sunk riveted vessels. But there remained skeptics, particularly in the established shipbuilding centers of the East Coast. These traditionalists pointed to every welding failure as proof that Kaiser's methods were dangerous. When a Liberty ship named the Schenectady broke in half while docked in calm water in January 1943, critics seized on the incident as vindication. Welded ships were unsafe, they declared. The entire Liberty program should be halted and redesigned using proper riveted construction. Kaiser's defenders fired back with data. Out of thousands of Liberty ships in service, one had failed due to a welding defect. The failure rate was a fraction of 1%. Moreover, investigation revealed that the Schenectady had suffered from a specific metallurgical problem related to low-temperature embrittlement, not from welding itself. The steel had become brittle in cold water, and a crack had propagated through the hull. The solution wasn't to abandon welding, it was to improve steel chemistry and add crack, arresters, structural features that prevented fractures from spreading. The debate raged through professional journals and government committees while Kaiser's yards kept building. Richmond Number Two, the newest and most efficient of Kaiser's facilities, had become the crown jewel of American shipbuilding. Workers there had refined every aspect of production. Materials arrived pre-cut and pre-formed. Cranes moved components with choreographed precision. Welders worked in teams, one starting where another finished, maintaining continuous production. The electrical systems, plumbing, and interior fittings were installed as sections were built, not after hull completion. By November 1942, Richmond Number Two had achieved a routine production time of 45 days. Ships slid down the ways with metronomic regularity. Every 45 days, another Liberty ship entered service. But 45 days wasn't fast enough. Not when German U-boats were sinking Allied shipping, faster than it could be replaced. Not when American forces were deploying to North Africa and the Pacific simultaneously. Not when the entire strategy for winning the war depended on overwhelming the enemy with materiel. Management at Richmond Number Two made a calculated decision. They would attempt something that had never been done, build a complete Liberty ship in less than 5 days. This wasn't about routine production. This was about proving what was possible, demonstrating to the workers that their efforts were part of something historic, and showing the world that American industrial capacity was limitless. The ship would be named Robert E. Peary, after the Arctic explorer who'd graduated from Bowdoin College in 1877. Josephine Peary, the explorer's widow who had accompanied her husband on polar expeditions, would serve as the ship's sponsor. The symbolism was deliberate. Peary had achieved the impossible by reaching the North Pole. Kaiser's workers would achieve the impossible by building a ship in the time most yards needed just to lay a keel. Preparations began weeks in advance. Every component was prefabricated to exacting specifications: hull sections, deck sections, bulkheads, the engine, the boilers, the propeller shaft, the steering gear, everything. Workers practiced the assembly sequence. Cranes were positioned. Welding stations were set up with backup equipment in case of failures. The entire yard was reorganized around this single ship. On Sunday, November 8th, at 12:30 in the morning, the keel was laid. What happened over the next 4 days would rewrite the rules of industrial production. Phyllis Gould and thousands of other workers poured into the yard in carefully coordinated shifts. They worked with the intensity of people who understood they were part of history. Hull sections, each weighing dozens of tons, were lifted by massive cranes and lowered into position. Welders swarmed over the joints, their torches creating a constellation of brilliant white stars against the darkness. The ship grew with visible speed. By Monday evening, the hull was complete. By Tuesday, the decks were installed. By Wednesday, the superstructure was taking shape. The engine, pre-assembled and tested, was lowered into the engine room and connected to the propeller shaft. Boilers were installed. Piping systems were connected. Electrical cables were run. The bridge was fitted out with navigation equipment. Observers from Washington and from traditional shipyards watched in stunned silence. This wasn't ship construction as they understood it. This was something entirely new, industrial production applied to objects that weighed thousands of tons. Thursday, November 12th. 4 days and 15 hours after the keel was laid, the Robert E. Peary was complete. Every system tested, every weld inspected, ready for sea. The launch ceremony drew enormous crowds. Josephine Peary christened the ship with the traditional bottle of champagne. Newsreel cameras captured the moment as the massive vessel slid backward down the ways and entered San Francisco Bay with a tremendous splash. 4 days, 15 hours, 29 minutes. The impossible had become real. The achievement made headlines nationwide. Life magazine featured the story. Newsreels played in theaters across America. The message was clear and unmistakable. American industry was unstoppable. No enemy could match this production capacity. Workers in other industries saw the headlines and understood that their efforts, whether building tanks in Detroit or aircraft in Seattle, were part of something larger. The industrial mobilization was working. Victory was possible. But the Peary record wasn't the end of the story. It was proof of concept. Richmond Number Two had demonstrated what could be achieved under optimal conditions with maximum preparation. The real question was whether this efficiency could be sustained in routine production. Could the yards maintain high speed while building dozens of ships simultaneously? The answer was yes. By early 1943, average production time across all Kaiser yards had dropped to 42 days. Some ships were completed in 35. The yards were launching 3 ships per day at peak production, 3 complete ocean-going cargo vessels, every single day. This rate of production was unprecedented in maritime history and would never be matched again. The workforce that made this possible was equally unprecedented. By 1944, Kaiser Industries employed over 96,000 people across all facilities. Women comprised roughly 30% of the workforce at Richmond. African Americans worked alongside whites at equal pay. The yards operated childcare centers so mothers could work. Kaiser had established comprehensive medical care for his workers, creating what would eventually become Kaiser Permanente, one of America's largest health maintenance organizations. The social impact was profound. Women who'd never worked outside the home discovered they could operate cranes, read blueprints, and weld steel just as competently as men. Phyllis Gould, the young welder who'd been a secretary 18 months earlier, later reflected, "From that point on, I always thought I can do anything I want to do. If I set my mind to it, I can do anything. And that's how I've lived the rest of my life." She was speaking for millions. African American workers found opportunities that had been closed to them in civilian life. The Richmond yards paid the same wages regardless of race. Black welders worked beside white welders. Black crane operators had the same responsibilities as white operators. This wasn't perfect equality. Discrimination and prejudice certainly existed, but it was progress that foreshadowed the civil rights movement that would emerge 2 decades later. The war had demonstrated that integration could work when economic necessity overrode social prejudice. But the human story shouldn't obscure the technical achievement. Welding had proven itself. The early Liberty ships, built in 1941 and 42, had accumulated enough service time to provide hard data. They were surviving Atlantic crossings in winter storms. They were surviving near-miss torpedo explosions. They were proving more durable than riveted ships of comparable design. The skeptics were running out of arguments. Even traditionalists had to admit that welded construction, properly executed, produced strong, reliable vessels. The war itself provided the ultimate validation. By mid-1943, the Battle of the Atlantic was turning in favor of the Allies. German U-boats were still sinking merchant ships. but Allied production had reached the point where losses could be replaced faster than they occurred. In 1942, U-boats had sunk over 700 Allied merchant vessels. In 1943, they sank fewer than 400, while Allied shipyards launched over 2,000 new ships. The mathematics of attrition had reversed. Germany couldn't win a war of production against American industrial capacity. Liberty ships were everywhere. They carried American troops to North Africa for Operation Torch in November 1942. They supplied the invasion of Sicily in July 1943. They delivered ammunition, food, vehicles, and fuel to Allied forces in Italy. In the Pacific, they supported the island-hopping campaign, bringing supplies to forward bases at Guadalcanal, Tarawa, and throughout the Solomon Islands. They crossed to Britain, filling British ports with the material that would eventually launch the greatest amphibious invasion in history. By early 1944, the Allies had achieved such overwhelming superiority in merchant shipping that strategic planners could contemplate operations that would have been impossible 2 years earlier. Operation Overlord, the invasion of Normandy, required moving over 150,000 troops plus all their equipment across the English Channel, and then supplying them continuously during the campaign to liberate France. This was only possible because Liberty ships and their successors, the larger and faster Victory ships, provided virtually unlimited logistics capacity. June 6, 1944. D-Day. Liberty ships sat at anchor off the Normandy beaches, waiting their turn to unload. They carried the tanks, trucks, artillery, ammunition, fuel, and food that sustained the largest military operation in history. Without these ships, the invasion couldn't have happened. Without the ships, there would have been no breakout from Normandy, no liberation of Paris, no advance into Germany. The entire Allied strategy depended on logistics, and logistics depended on ships. Henry Kaiser's innovation, that simple decision to weld instead of rivet, to build in sections instead of sequentially, to hire anyone who could do the work regardless of gender or race, had made possible the industrial surge that won the war. 197 days to build a ship had become 42 days. 6 months had become 6 weeks. The time savings were enormous, but more important was the multiplication of capacity. Traditional methods might have produced 500 Liberty ships by war's end. Kaiser's methods produced 2,710. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The ships themselves were built to be disposable, but they refused to disappear. Many Liberty ships survived the war intact. Of the 2,710 built, only 200 were lost to enemy action, a remarkably low casualty rate considering they operated in war zones for years. After the war, many continued in merchant service. They carried cargo for commercial shipping companies throughout the 1950s and 60s. Some remained in service into the 1970s, far exceeding their intended lifespan. 2 Liberty ships survive today as museum ships, the Jeremiah O'Brien, berthed in San Francisco, and the John W. Brown in Baltimore. Both are maintained in operating condition and occasionally make commemorative voyages. Visitors can climb aboard, walk the decks, and get some sense of what it was like to serve aboard these vessels. The ships are cramped, Spartan, and uncomfortable by modern standards, but they're also testament to the era when American industry performed miracles. The welding revolution that Kaiser championed didn't end with World War II. Welded construction became standard in shipbuilding worldwide. Modern container ships, tankers, and naval vessels are all welded. The technique Kaiser fought to legitimize is now so universal that few people remember it was ever controversial. Modern shipyards use advanced welding, technologies like submerged arc welding and friction stir welding, but they're all descendants of the electric arc welding that Phyllis Gould and thousands of other workers used at Richmond in 1942. The prefabrication methods also became standard. Modern ships are built in massive sections, fabricated separately and then joined, exactly as Kaiser pioneered. Japanese and Korean shipyards, which dominate commercial shipbuilding today, Use production methods that would be instantly recognizable to someone from Richmond Shipyard Number Two. They refined the techniques, improved the efficiency, and automated much of the process. But the fundamental approach, build sections separately and assemble them quickly, remains Kaiser's innovation. The social legacy is harder to quantify, but perhaps more important. The millions of women who worked in war industries during World War II proved conclusively that gender wasn't a reliable predictor of capability. Many returned to domestic life after the war, pushed out by companies eager to give jobs to returning veterans. But the experience stayed with them. They'd earned real wages, gained real skills, and proven themselves in demanding work. When the women's movement gained momentum in the 1960s and 70s, many of the activists were women who remembered what it felt like to be valued for their work, rather than their appearance or domestic skills. The integrated workplaces at Kaiser's yards provided a preview of what American society could become when economic necessity overrode prejudice. Black workers and white workers performing identical jobs for identical pay wasn't revolutionary ideology, it was practical efficiency. But it demonstrated that integration could work, that people of different races could cooperate toward common goals. This wasn't the civil rights movement, which would require years of struggle and sacrifice, but it was evidence that change was possible. Henry Kaiser himself became a Toomer's national figure during the war. He was featured on magazine covers, celebrated as the man who outproduced the enemy, consulted by government officials on industrial matters. After the war, he leveraged his reputation and wealth into new ventures. Kaiser Aluminum became a major producer. Kaiser Steel operated mills in California. Kaiser Motors built automobiles, including the distinctive Henry J. compact car and the Kaiser Frazer sedan. His automotive ventures never achieved the success of his shipbuilding, but they demonstrated his restless energy and willingness to tackle new industries. Kaiser Permanente, which grew out of the medical services he'd provided to shipyard workers, became his most enduring legacy outside shipbuilding. The integrated prepaid health plan he'd created to keep workers healthy and productive evolved into one of America's largest healthcare organizations, serving millions of members decades after Kaiser's death. The concept of preventive care, regular checkups, and coordinated treatment that Kaiser Permanente pioneered changed American medicine. But Kaiser's greatest contribution remained those ships, 2,710 Liberty ships, each one capable of carrying 9,000 tons of cargo. Together, they displaced 29 million tons, an absolutely staggering figure. If you lined up every Liberty ship ever built bow to stern, they'd stretch over 100 miles. The cargo capacity was sufficient to move the entire material requirements of a modern army multiple times over. The economic impact was equally profound. Total cost for the Liberty ship program was approximately $3 billion, roughly $45 billion in current dollars when adjusted for inflation. This sounds enormous until you consider what was purchased. A merchant fleet larger than the entire pre-war American merchant marine. A fleet that operated continuously for years, delivering countless tons of cargo to every theater of war. The return on investment was incalculable because the investment enabled victory. American industrial production during World War II remains the most impressive economic achievement in history. The United States produced 2/3 of all Allied military equipment, over 300,000 aircraft, 86,000 tanks, hundreds of thousands of artillery pieces, millions of rifles, billions of rounds of ammunition, 2,000 naval vessels of all types, and 2,710 Liberty ships. This production was only possible because industrialists like Henry Kaiser reimagined manufacturing from first principles, discarded centuries of tradition when tradition impeded progress, and mobilized workforces that previous generations would have thought impossible. The Axis powers could never match this output. Germany's industrial base, while sophisticated, was smaller and increasingly disrupted by Allied bombing. Japan's industry was even more limited and critically dependent on imported raw materials that Allied submarines interdicted. Italy's industrial capacity was minimal. The Axis fought with skill, determination, and often superior tactics, But they couldn't overcome the fundamental mathematics of industrial production. American factories produced more of everything, faster than the Axis could destroy it. This production didn't happen automatically. It required vision, organization, and the willingness to challenge conventional wisdom. Henry Kaiser exemplified all three qualities. When experts told him ships couldn't be welded, he welded them anyway and proved the experts wrong. When traditionalists insisted experienced workers were essential, he hired secretaries and housewives and trained them in weeks. When society said women couldn't do heavy industrial work, he gave them welding torches and stood back. The results spoke for themselves. 4 days, 15 hours, 29 minutes to build a ship that weighed 14,000 tons. 42 days as a routine production time. 3 ships per day at peak output. These weren't just impressive statistics. They were proof that American industrial genius, properly directed and freed from unnecessary constraints, could achieve things that seemed impossible. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.